Hey everybody, in preparation for this week's exam, I've been getting some questions about how to solve some of the weekly thought-provoking questions, particularly weeks 3 through 5, where there were calculations that you had to do. So again, you can reopen those assignments using the directions that are located on iLearn. If you go under that assignments tab, you'll see that under the folder for the assignment that you want to reopen. And in there you will see not only the answer you put, but the correct answer. But with that in mind, let's go through just some brief explanations on how to solve these types of questions, just to make sure you can do that should you have to on the test. So from week 3, the first of the 3 questions had to do with this particular chart here. So suppose a firm has 3 sources of energy: coal, natural gas, and solar power. The firm needs 12 units of energy from these 3 existing sources in order to meet their production needs. Using the idea of this equal marginal principle, how many of these 12 units of energy will come from coal? And then the next 2 questions ask how many are going to come from natural gas and solar power. So let's go through and see if we can answer these questions, right? So again, you always want to take it from the cheapest source first. So your very first unit, do you want it from coal, natural gas, or solar power? Well, coal is the cheapest. So again, the first source is going to come from that. Now for your second source, you can choose from the second unit of coal, which is $80, the first unit of natural gas, which is $75, or the first unit of solar power, which is $95, natural gas being the cheapest of that group, right? So again, that would be where your second source comes from. And you just go through and you pick which sources are the cheapest based off of what you have left. So your third source, you can either go from your second source of coal, which is 80, your second source of natural gas, which is 98, or your first unit of solar power, which is 95. And I think we're going to go coal here. For your fourth source, again, now you're comparing coal, which is 100, natural gas, which is 98, and solar power, which is 95. So for the first time, you're going to go solar. So that's where the fourth source is going to come from. Right, now that fifth source, again, you got coal for 100, natural gas for 98, and solar power for 122. So you're going to go natural gas on this one, which is that fifth source. Right, now the sixth one, you've got either coal for 100, natural gas for 120, or solar power for 122. You're definitely going to go coal here. So that's 6. Your seventh source, again, you got your fourth source of coal at 118, your third source of natural gas at 120, or your second source of solar power at 122. Right, again, you're going to go coal, which is, oh, didn't mean to do that. So again, that's where your seventh is going to come from. Now your eighth is either coal for 130, natural gas for 120, or solar power for 122. You're going to go natural gas on that one, right? And then it's either 130 for coal, 130 for natural gas, or 122 if you use that second unit of solar power. So you're going to go solar here. Oh, I don't know why that keeps doing that. The screen is getting sensitive. So you're going to go ninth for that one, right? Okay. So now for your 10th, 11th, and 12th units, you notice that coal, natural gas, and solar power all have the same price. So it doesn't really matter what order these are in. In other words, you get them right on the exam if you put them in any order, right? But you, just to go from left to right, we do 10th from coal, 11th from natural gas, and the 12th from the solar power, right? Now, the question asks you how much is going to come from coal. And in this particular case, it looks like we have 5 units of coal being used as our source. How much is going to come from natural gas was the question 2. That's going to be 4. And how much is going to come from solar power? It looks like you're going to have 3 sources from there, right? So again, that's how you'd answer that question on the exam. With that in mind, let's move on to the second question for that particular week. It says that a farmer needs to decide how many pounds of fertilizer to use when cultivating his fields. The total benefits measured in revenue generated by this crop yield, as well as the total cost of each pound of fertilizer, is given in the table below. What's the optimal number of pounds of fertilizer that the farmer should use for his fields? And I go ahead and give you the hint to calculate marginal benefits and marginal costs, and then follow that profit maximizing rule. All right. So marginal benefits is just the change in total benefits as you produce another unit, right? So when we're going from, say, 1 unit to 2 units, our total benefit goes from 70 to 130, right? That is a change of $60, right? That's the marginal benefit of adding that first unit of fertilizer. If you're adding that, that second unit of fertilizer. If you're adding that third unit of fertilizer, we're going from 130 to 180, right? You're looking at marginal benefit of 50. As we go from 3 to 4, it looks like our total benefits go from 180 to 220. That's 40. Right, as we go from 4 to 5, you can see the total benefit goes from 220 to 250, which is 30. As we go from 5 to 6, again, you see it increase by 20, then by 10, then by 0. Right. Now, if we wanted to calculate out the marginal cost, again, that's just the change in total cost as we go from one unit to the next. So as we go from $1 to $5, the marginal cost of producing that second unit or using that second unit of fertilizer is $4. Right. As we go from 2 to 3, it's looking like 8. As we go from 3 to 4, you got 12. As we go from 4 to 5, 16. As we go from 5 to 6, that is 20. And then as we go from 6 to 7, that's an increase of 24. And as we go from 7 to 8, that's an increase of 28. Right? And in looking at that, you can see that following the profit maximizing rule, which is where marginal benefits intersect is equal to our marginal cost, that happens right here. So 6 units of fertilizer is the answer you were looking for. Now, if you had stopped at 5 because that 6 unit doesn't add any extra benefits above the marginal cost, that's not necessarily incorrect. In other words, if you had put 5 there, then you should have also gotten credit. But the answer I was really looking for is 6 because that's essentially following this marginal benefit equals marginal cost rule. Right. In other words, really like anything between or anything up to like 5.9 would add benefits to cost, right? So 6 is the answer I'd be looking for on the exam. Although if you did put 5, I believe I gave you credit on the thought-provoking assignment, just because again that 6 unit doesn't increase your profits at all. It just doesn't reduce them at all. It just doesn't reduce them either. Right. So again, that is the answer you're looking for, where marginal benefits equals marginal cost if you have to calculate out those two things. All right. And then the other question for week 4 here, in fact, all 5 questions have to deal with this particular setup. So you're investigating the market for converting grass lawns to desert landscapes, assuming that a landscape is a competitive market. Suppose the herbicide you use to convert grass lawns to desert landscapes has a runoff that causes a total external cost of 800 Q. Remember that the marginal external cost is just the derivative of the total with respect to Q, so that's equal to 800. And I go ahead and list out those equations there. So I'm going to go ahead and exit the full screen mode so that we can use some different colors here. So let's start off with our graph here. First thing we need to do is go ahead and find out where this demand curve is going to start. Remember how you do that? You're going to set Q equal to 0, and then our price is going to start at 5,000. Right, so 5,000 is where we'd start this particular demand curve. Then you have a relatively steep demand curve looking something like that. And if you want to find out where that hits the x-axis, then you just set P equal to 0 and solve for Q. And when you do that, then you should get that Q is equal to 1,000. So that's where we hit that x-axis. Now we also need to figure out where the supply curve is going to start. So again, you set Q equal to 0, and we know that P is equal to 200. So we're going to start somewhere down here on this vertical axis at 200. And you have a supply curve that is somewhat flatter than that demand curve. Right, again, the magnitude of that slope is smaller. All right, so again, we're going to have an intersection here. This is going to be our market equilibrium that produces this much at this price. And if you want to solve for EM, then you just have to set supply and demand equal to each other, right? So we've got 200 plus 3Q equal to 5,000 minus 5Q. and then we just get all of our Q's to one side. So you add 5Q to both sides there. We got 8Q over here. Subtract 200 from the other side. You got 4,800 over here, right? So we know that our QM is equal to 600. All right, and in order to figure out the equilibrium price, you just plug that 600 into either of these two equations, right? So PM is equal to 5,000 minus 5 times 600, or you can also get it as 200 plus 3 times 600. Either way you do it, you should get 2,000. So our equilibrium price here is $2,000. So that should get you to the answers to the first couple of questions, questions 1 and 2 there, which asks you for that actual quantity and actual price. Now remember, this is a market that contains a negative externality or a marginal external cost of 800, so we need to factor that into this problem here, right? So remember that we need to calculate the marginal social cost curve, which is equal to supply plus your marginal external cost, which in this case is going to be equal to 200 plus 3Q plus our marginal external cost of 800, right? So that's going to be 1,000 plus 3Q there. Right, now again, we can graph out this marginal social cost curve by setting that Q equal to 0. If we do that, you can have a supply curve that looks something like this. So again, this is our marginal social cost curve, and it's going to start right here at 1,000. And where that intersects our old demand curve, that gives us a new equilibrium. This is the socially efficient or socially optimal equilibrium, which we'll call E star. Right, that's going to give us our new equilibrium quantity, Q star. That's the socially efficient or socially optimal quantity. And this is going to be the socially efficient or socially optimal price, P star. Right, and so again, we can solve this equilibrium here by setting that marginal social cost curve equal to our demand curve. So we've got 1,000 plus 3Q equal to 5,000 minus 5Q. Right, again, get all our Q's to the same side. We got 8Q is going to be equal to 4,000, or Q star is going to be equal to 500. So we got 500 here. And then again, if we want to figure out or solve for price, we can do that by plugging that Q star into either of our equations. So remember that you want to plug it into the equations you use to get that Q star, so MSC or demand, right? So the MSC equation is 1,000 plus 3 times 500, and then our demand is 5,000 minus 5 times 500, right? Either way you do it, you should get 2,500 as your price, your P star. So as is normally the case when we have a negative externality or a marginal external cost involved, then you're producing more than what society wants us to, right? So last thing we're going to do here is we're going to calculate out some dead weight loss. This is, I think, the part that a lot of people are having trouble with. So remember, dead weight loss is stemming from the fact that we're producing 600 when we really should only be producing 500 from a socially efficient or socially optimal standpoint, right? So in other words, the fact is that we are just producing too many units given that we're causing this negative external harm. And so our dead weight loss is measured by that triangle there, right? And so we need to figure out the dimensions of that triangle, where the formula for calculating the area of a triangle is 1/2 base times height. So we know the base of that triangle is 100. So we also need to figure out what the height of this triangle is. In order to do that, we need to figure out this number where that QM is on our marginal social cost curve. So our MSC at QM, where our QM being equal to 600, is really what we're looking for to get that number. right? So our marginal social cost curve is 1,000 plus 3Q, and the Q we're going to use is that QM equal to 600. So again, that's going to be 2,800 as our height of that triangle there. And the difference between that and our original market price of 2,000 should be exactly equal to the 800 and marginal external cost that is given to you in the problem, right? So again, that's the those are the dimensions that you are looking for. So our deadweight loss, which I'll do over here, is equal to 1/2 base times height, or 1/2 100 times 800, or 1/2 of 80,000, which should be 40,000. All right, so that's the answer that you are looking for there when calculating out that dead weight loss. All right, so that's how you do it. I think dead weight loss is the one that gives most people the trouble. Most people want to look for the difference between these two numbers, 2,000 and 2,500, right? Don't do that. If you do that, you're going to get it wrong, right? Make sure that you are looking for, again, the where we hit that MSE curve at QM for the height of that particular triangle. All right, so with that in mind, let's go ahead and move on to the last question, the one from week 5, which is kind of the mirror effect of this question in that we're looking at a positive externality and not a negative externality. So this one reads that the honey production industry has the following market demand and supply equations that I give to you there. The production of honeybees requires the raising of honeybees, which pollinates the surrounding countryside and increases the proliferation of flowers and fruit production for the neighbors of the beekeepers. Assume the marginal external benefit of this is $60. Right, so let's go ahead and again start graphing this out. So if there's anything you did not understand regarding the last problem, the good news is that this will be kind of a review of that, just using these positive externalities instead. So we're kind of going to go through it all again. All right, so again, we need to figure out where this demand curve originates. In order to do that, we've got to set our Q equal to 0. So our price is equal to 120. So again, when we start this demand curve, we'll start it here at about 120. And you have a somewhat steeper demand curve looking something like this. And if you want to figure out where it hits that x-axis, then you just got to set P equal to 0, solve for Q. Q looks like it is equal to 40 there. And if you want to figure out where the supply curve originates, then again we set Q equal to 0, and our price is equal to 20. So it originates somewhere around here. Again, your supply curve is going to be slightly flatter than your demand curve because the magnitude of that slope is slightly smaller. 2 is less than 3. All right, so again, where do the two intersect? This gives you your market equilibrium here, QM. Gives our equilibrium quantity. And PM, our equilibrium price. Okay, so again, if we're trying to solve for our actual market equilibrium, you just set supply equal to demand. So 20 plus 2Q is equal to 120 minus 3Q. Add our Q's over to the other side there. We got 5Q is equal to 100. So we know that QM is equal to 20. We also know that we can plug that 20 into either the demand or the supply equation to get PM. So that's 120 minus 3 times 20, or if you prefer to put it into the supply equation, that's 20 plus 2 times 20. Either way, you should get 60. Again, it's always good to do it both times. Just check and make sure that you got the same number. It means you did your earlier math correctly. All right, so now we need to figure out what happens when we put in this externality. So we got a marginal social benefit curve that we need to figure out by adding to our demand curve the marginal external benefits. Right, so the demand curve is 120 minus 3Q, and we're adding to that the 60 and marginal external benefits that these bees are causing through their pollination efforts. Right, so that's going to be equal to 180 minus 3Q. Right, and then once again we can set our marginal social benefit equation equal to our original supply equation in order to figure out our new E star, right? So, but first of all, we got to figure out where we're going to originate this marginal social benefit curve from. And we do that by setting Q equal to 0. We know that this curve is going to start at 180. Again, it should be exactly 60 higher than our original demand curve at all points. Right? So you're going to have a marginal social benefit curve that looks like that. Again, if we set P equal to 0, then our Q is going to be equal to 60 just by solving for Q in that marginal social benefit equation. All right, so we need to set MSB equal to supply in order to figure out that E star, or our market equilibrium. So we can get our equilibrium quantity, Q star, and our equilibrium price, P star. All right, so with that in mind, we've got 180 minus 3Q equal to 20 plus 2Q. Again, we're going to get all of our Q's over to one side, so we got 5Q is going to be equal to 160. And so that we know our Q star is going to be equal to 32. And then we can plug that into either or both equations, either MSB or original supply, and we should get our P star. So our P star is equal to 180 minus 3 times 32, or you can plug it into the supply equation, P star equal to 20 plus 2 times 32. Either way you should do it, either way you do it, you should get the same number, and that number is 84. So as is typically the case with positive externalities, again, the price is too low, and the quantity that we are producing is too low. In other words, the market would be happier if we were producing 32 units instead of 20. So the deadweight loss that exists here exists because we are producing too few. In other words, from a market standpoint, we wish that we were producing 32 units because of all the external benefits that this production creates, but we're only producing, say, 20 units, right? So we got this deadweight loss triangle. In order to figure that out, you need to figure out, again, what happens when you plug your QM into our marginal social benefit curve. So our MSB at QM equals 20 units is equal to 180 minus 3 times 20, or 180 minus 60 is equal to 120, which again should be exactly 60 higher than our original market price of 60, right, given that our marginal external benefit is 60, right? So again, if we're trying to calculate deadweight loss, it is the height of this triangle, or 1/2 base times height. So remember that the base of this triangle is the difference in the number of transactions, which is 12. And the height of this triangle is the difference there, or the exact amount of our marginal external benefit, which is 60. All right. So that is 1/2 of 720, which should be equal to 360. And that's the deadweight loss created in this particular market, which again is, I think, the part that most students were having trouble with. Right, so there's a couple of examples of how to do those types of questions. Be able to do one of these involving either negative or positive externality on the exam. There'll be most likely a question like that on there, and make sure you're able to calculate that deadweight loss when doing this type of question. Right, so anyway, I hope this was useful for you. I kind of did it as a response to some popular demand from a few emails asking for me to go through those solutions. So there is that video now for you to review. Again, just let me know if you need anything else. Happy studying, and good luck on the exam coming up.